good thing is today we're going to talk about an ellipse, and although it looks like there's a whole lot of stuff here, an ellipse is really what you would probably call what? An oval. But smart math people like to call it an ellipse. We talked about these conic sections. We spent a long time on problems, it seems like, this week. But remember that you have that cone, and you can slice the cone in different ways. And if you slice the cone parallel to the cone, it makes a circle. Well, if you slice it at a slant, it's going to make an oval. And so here's the definition. It says it's the set of all points in a plane such that the sum of two fixed points is constant. These two fixed points are called foci. Here's a little English for you. Remember in a parabola we have a focus? Well, in an ellipse, there's more than one focus. Like, here's a focus, and here's a focus. But we don't say focuses. We say foci. I say foci. I don't know. Maybe it's foci. I don't know. I always say foci. But the idea is that if you pick any point on this ellipse, if you draw a line to both foci, that sum will be the same all the way around. And so I have this cute little demonstration to show you here at wolfram.com. Mr. Dorsett, he works for Wolfram now. Did you know that? You guys even know who he is? Ooh, I saw Mr. Wise. But look, here are my two foci going all around the ellipse. And that sum is the same all the way around. Isn't that super cool? You don't seem that impressed, but... Well, I can't really stop it. But I used to do this with a piece of cardboard, and maybe I should just go back to that, but I try to be cool and use technology now. But I used to have this piece of cardboard, and I would put a thumbtack here and a thumbtack here, and I would take a piece of string and put a pencil at the end of it, and I could just take my pencil and pull that string, and it would make an ellipse every time. Because if I added up these two red lines all the way around, that distance is the same all the way around. And you can make an ellipse from that. Isn't that kind of cool? It's kind of like a circle, but a circle just has that one point in the middle that's a center, and all the distance is the same all the way around. For an ellipse, there's these 2 points that are called foci that you can add that up all the way around. Huh? You're not that impressed, but I think it's kind of cool. Thanks, Stephen. In an ellipse, there are two axes of symmetry. There's the major axis. I've always called it the major axis. Your book calls it the focal axis because the foci are on the major axis. The major axis is always the longer axis. So it's really easy to tell which one's the major axis by looking at it. And the minor axis is the shorter axis. What would this shape look like if the major axis and the minor axis were the same length? Circle. It would just be a circle. So a circle is like a special ellipse, just like a square is a special type of rectangle. You agree with that? Like a square is just a rectangle that happens to have all four sides equal. A circle is an ellipse where the major and the minor axis are the same. And where they intersect is called the center. And guess what we're going to call the center in our formula? What letters are we going to use for the center? H and K. That's right. All right, so there's kind of a whole lot of stuff to go with this, but let me just give you this one more thing here. The distance from the center to the end point of the minor axis is always what we're going to call B. The distance from the center to a focus is always going to be called C. And then A is actually the distance of how long the major axis is, but it also works out that if you go from the focus and you draw in a little diagonal here, you see how this makes a lovely little right triangle? This is what we're going to call A, which means we can use Pythagorean theorem to relate A, B, and C to each other, but it's kind of tricky because normally what is the longest side of a right triangle when we're thinking of A, B, and C? The hypotenuse, which is normally we think of C, but in an ellipse, A is going to be the longest side. So I want you to write out here that A squared equals B squared plus C squared. If you know two of the three letters, you can use Pythagorean theorem to find the third one, but you have to remember that A is always going to be the biggest number. A has to do with the major axis, and we'll get there in a second. Okay? You got that? So this is my little formulas here. Remember I told you you're not really going to have to memorize all this. I just want you to be able to use it. So this is just like with the parabolas. I'm going to give you two charts. If the center's at the origin, and then when it's just at HK. When it's at the origin, it looks so much nicer because there's no other numbers going on here. But notice that we have fractions in here. X squared over a squared plus y squared over b squared. And in an ellipse, it's always going to be equal to 1. Focal axis, I'm going to write the word major axis here again because I know I'm going to end up saying that because that's what I've always said my whole life until I taught on this book. If it's at the origin, if x squared is over a squared, the major axis will always be horizontal. And if it's y squared over a squared, then the major axis will be going up or down. So you can kind of draw this if you want. Like if the major axis is horizontal, it kind of looks like my last one where it's an oval going like this.
Teachers, please excuse the interruption. All computer labs during the ISET, please log off with your computers at this time. Please log off your computers at this time. This is not a computer lab.
Are they doing ISET right now? I thought ISET started Monday.
They're doing key testing, or key lines,
Work keys.
work.
Is that on the computer?
I don't know if it's work.
If you're getting a technical honors diploma, you have to take this work keys test. Like it's just one of the requirements. I don't really know much else after besides that. Foci are always going to be the length from the center to that focus. It's always going to be C. So if it's at 0, 0, if it's the major axis, it's going to be on the x-axis, so plus or minus C0, 0 plus or minus C. And then here's a really nice thing. The length of the major axis or the focal axis is always going to be 2A units, and the length of the other axis, the shorter axis, is always going to be 2B units. So I like to throw in here to remind you that A is always going to be the bigger number. So when you see an equation, A is not necessarily going to be the first number, but A is always going to be the bigger number. And so I just threw in here that A and B both have to be bigger than 0, and B will always be smaller than A. Okay? Ready to do an example? This isn't very exciting to just write all this stuff down.
Wait, how are we doing an example? The next slide is.
Oh, did I not give an example yet? I gave you the HK stuff next. Dang it. Okay, almost ready for an example. Aren't you glad I didn't make you write all this out? Don't you think this is a good plan? I should just do this all the time and just kill lots of paper and print these notes out. Think how much more we could learn.
Think how much faster we could get through.
Well, which means we could even do more.
Or not.
All right, so just like with parabolas, we have the 0, 0, and then we have the center if it's not at 0, 0. Do you agree you could use this chart if the center was at 0, 0? Because you could just plug in 0 for H and 0 for K. Just like a circle, if there's something added or subtracted with your X or Y, then that means it's not going to be centered around the origin. And I just noticed this is all very similar. The foci now, instead of just being plus or minus C0, we have H and K thrown in there. Also, I threw in some formulas for the vertices. The vertices are the endpoints of the major axis or focal axis. And I'm really not going to spend a long time on this page since it's all written out for you already. Don't you feel like you learn more when you write all this down, though? I feel like I do. Like if I keep printing my notes out, I feel like I don't learn as much. That's why I'm not a big fan.
As long as we like, you don't print out the work that we work so much on this. I think it's better this way.
Oh yeah, we'll see. We'll see how the next test goes, right? That'll be our little. Hopefully it'll be better than the last one, and I can be like, well, obviously printing the notes out now. Find the vertices and the foci of the ellipse and sketch the graph. 3x squared plus 4y squared equals 12. Does that look like the standard form of the equation of an ellipse?
Yes.
What does an ellipse equation have to be equal to every single time?
1.
This is not equal to 1, it's equal to 12. So how could I make that equal to 1? divide by 12. So if it's not in standard form, you've got to put it in standard form. So the first thing that I'm going to do is I'm going to divide everything by 12. And remember, we want those fractions there because that's going to give us our a squared and b squared values. So we're just going to simplify that, and I think we should get x squared over 4 plus y squared over 3 equals 1. Do you know which one is a? Or a squared, I guess? A squared is always the bigger one. So if it's in standard form, you know a lot just by looking at it. You know that this is a squared, so if a squared equals 4, you know that a equals...
Wait. How do you know that's A?
And not b?
Yeah.
Because a is always the biggest number, always.
But, because I'm thinking 1/3 is bigger than 1/4.
But it's about what's there when you simplify the problem, right? Like, if we go back to our thing here, like, it's what you have when you just have x squared over a number, y squared over a number. Like, it's not what it is before you simplify that fraction. Does that make sense?
Yeah.
Like, you can't even think about what's a, what's b until you have it in standard form. So until you have just x squared over the number, you can't look at it and say, oh, let me look at 3/12. You see what I'm saying?
Yeah, but like in standard form, it just, like, at first, before you even write that down, I wrote down 1/4 times the quantity of x squared. And so that's why I thought 1/4 and 1/3 is bigger than 1/4.
I see what you're saying, but we're not saying that a is like what's out in front of here. You see what I'm saying? Like, we're not saying it's, I don't know if that makes any sense or not. Like, you're right. Like, you could write this as 1 over a squared in front of that, but it's still what is the bottom number is all we're looking at. We're not looking at what is the fraction in front of that. Okay. Does that make sense? Okay. Sorry, I never really thought about it that way before. So it's just which one is the bigger number on the bottom when you look at it. And so this one is b squared equals 3, which means what does b equal? The square root of 3, which is not going to be that pretty to graph, but we can graph that. It's like 1.7. Feels a little more than 1.7-ish. We'll just leave it about that. What is my center on this one?
Origin?
Yeah, there's nothing on top, so the center is just a 0, 0. Let's do what it asks first, and then we'll look at graphing it. Find the vertices if we go back, I'm going to just double slide this for a second here. If we go back, I didn't give you vertices on the first ones, but we can just plug in 0, 0 for h and k. Because x squared is over the bigger number, x squared over a squared, do you agree I'm dealing with the first column here, the horizontal one? Yes? Yes? So that means my vertices are h plus or minus a comma k. And so just like we did with parabolas, we're just going to plug that stuff in. Since the origin is our center, it's just 0 for h and k, which means it's really kind of nice here because it's just going to end up being 0 plus or minus a comma 0. Just a, really. So that would be plus or minus 2, 0. And I'll show you in a minute when we graph this that maybe you'll want to graph it first because you can tell the vertices really easily after you graph it. What about the foci? Can I find the foci with what I have right now? What's the foci coordinates? You have to find C. C is not in the equation. Only A and B are in the equation. So what are you going to have to do to find C?
Over b squared. Never mind. I have no idea.
We're just going to use Pythagorean theorem, right, Sarah? So you're going to do like, you're going to have to subtract that over, right? I think you were just dividing, right? I think if you wrote it down, you would have got it right. So you just have to remember that if you know A and B, you can plug that in to find C. I'm just going to go ahead and square these. I know this is A squared and this is B squared, that's just going to be 4 equals 3 plus c squared. So that works out really nice. That c equals 1. Do you agree with that? The foci are those points inside inside the ellipse. And if you go back and you look at your foci, I think for 0, 0, it was just plus or minus c0. So it's just plus or minus 1, 0. Just kind of practicing using that chart just like we did with the parabolas. So let's look at graphing this. I find graphing these very similar to graphing a circle. The only difference, it's not the same distance all the way around.
They have to graph -0 and -0.
Yes. Because those are going to be your endpoints of your major axis, or focal axis. So when I graph this, I start just like I do when I'm graphing a circle. And I'm going to start with the center. And my center is 0, 0. Couple things we can do here. We know the vertices already, so we could just graph -2, 0 and +2, 0. But I also want to show you how you can just look at it and graph it as well. Since this is A is 2, do you agree that the focal axis is going to be 4 because the focal axis is 2 times A? And so if I know this has to be 4 all the way across, I could just go 2 to the left and 2 to the right, and that makes a length of 4. Notice those points are my vertices every time. My minor axis is going to go the other way. My minor axis is going to be 2 times B, which we could do 2 times B. But also, could I just go up B and down B, and would that give me that minor axis length every time? So the big difference between an ellipse and a circle, it's not the same all the way around. This one's pretty close to the same. If I go about up 1.7 and down 1.7, that would be my minor axis. And then the thing that I like the most about ellipses is my circles tend to always look like ellipses anyway. That's a terrible ellipse, but I like how I redraw that. That would be your graph. Your foci would be inside there, and you don't have to graph the foci, but this one worked out so nice it's not even an ugly number. The foci in this one would happen to be right here and right here. And that's where, using that little picture on the internet, if you drew a line to any point on the ellipse, the sum of the distance from the foci to the ellipse would be constant all the way around. Okay? It's not terrible, right? I like ellipses. I agree. So try this one if you haven't already. This one is already in standard form. How do I know? It looks to me like it equals 1. It's x squared over a number plus y squared over a number. See if you can figure out which direction it's going to be. Is the major axis going to go horizontal or vertical? Use the center and use A and B and see if you can sketch a quick graph of this to see if we agree on it. Whole bunch, but I did. A squared, yes. So it's the bigger one, so that means that A equals 8 and B equals 6. We did ellipses in algebra 2 last week, I think, and some of the kids got really mad if A ended up being the second one because they said A is always the first number. It doesn't matter what order you add it, so just remember to make sure you look at that because sometimes they're going to throw it in as the second number to just see if you're paying attention. And then I wanted to do this one to show you that if they don't ask you to list the vertices, they don't ask you to list the foci, that you don't have to do a whole lot to graph this if you remember that the major axis is going to be twice this length. So wherever your center is, you can just go 8 in either direction depending on if it's made horizontal or vertical. And then this is your minor axis is going to be this many in both directions because it's going to be twice that. And you get a pretty quick graph here, which is why I think I like it better than parabolas. So if I was graphing this, I'm going to start at 0, 0. And is the major axis going to be horizontal or vertical? Because x is under, or A is under x. So I'm just going to go 8 to the left, 8 to the right. And my minor axis is going to be 12. So I'm going to go up 6 and down 6. And I'm going to connect that. And like I said, I feel better, somewhat better about graphing these because I feel like my circles always look like this anyway. Oh. Maybe, yeah. I feel kind of good about that. It's not such a bad lesson today. It's a good before prom lesson. A party? No. You should take calculus because I don't give you any homework. I didn't give you any homework practice today. We had breakfast today.
You can't favor classes like that.
I really did it. They really have homework to like look over stuff, but they don't have anything to turn in right now. But they just took their practice AP test. Like they took it all week this week for 4 days. We timed it and I graded it with the rubric, and they were amazing scores. So that's why I brought my breakfast because I was very proud of them. Every student but one person got a 3, 4, or 5 on my little practice exam, and so they like to pretend that they're not that smart kids, but they just rock down on the practice exam. So that's why I brought my breakfast. Switch Alex, both of them. How did she cheat?
No, she didn't cheat. She just forgot she had something.
She can take the questions. Like they had to do it each day, and so like they couldn't go back and do anything the next day. Does that make any sense? Did you graph this one already? Hold on, let's go first, Sarah.
So A is 7.
Because A is the biggest one, not the first one. So you're right. This is A squared in this one, so A is 7. So what else is different about this one when you notice that A is
It's going to be vertical.
it's going to be vertical because A is under Y, so that means your major axis should go up and down, not left and right. Caitlin, what was your question?
Would the order be different?
Because the center, this is the first one I've had where it's not just x squared and y squared on the top. And so what would the center be on this one? Yeah, remember it's x minus h, y minus k, so we have to change the opposite sign, so negative 2, 5. It doesn't fit on the graph? It's close though, right? You can kind of approximate it, right? Since it's vertical, I'm going to go up 7, down 7. 1, 2, 3, 4, 5, 6, 7. That's a pretty close estimate. 1, 2, 3, 4, 5, 6, 7. And horizontally is going to be 3. So I'm going to go 3 and 3. Right? Because this is b squared, so b would be 3. Do you agree with that?
Yeah, I did 2 and 5, so it's
Oh, you did the center. Okay, I was like, where did you get 5 from? All right, let's see how bad this will look when I graph it. I kind of totally missed the point, but that one definitely looks like a football. I think that's it, right? I kind of broke this up in 2 days, different than parabolas, and then I gave you both formulas today, and you're kind of going to practice more graphing today, and then on Monday we're going to practice writing equations and talk about this really cool word called eccentricity. Isn't that an exciting word? It's a good like spelling bee word. Eccentricity. How do you spell it? ECCENTRICY.
We're gonna talk about ellipses.
Talk about what?